M1L5 does not provide any new things to learn per se, but just it's a section called putting it all together. And so really this is just a chance to practice multiplying polynomials, dividing polynomials, and then to be able to recall what to do if you need to add and subtract. Nowhere in this section does it say that you need to use tabular method versus distributive or tabular versus long division. You get your choices through all of these. There are plenty of practice problems in here. They're all exercises. There's no examples. I'm going to work through a few just to remind you of what it is that we've been doing. And then, once you think you've seen enough, you can go ahead and stop the video and then move into the problem set. So if we look at this one, I look at the indicators and I see that there is multiplication. So let's say we just make a couple of notes, right? This is going to be multiplication. It's a bad looking M, so we'll start that over. So we're going to multiply, and we see that we're missing the linear term, so we might want to make a note that we're going to need to rewrite this one as x squared plus 0x and then minus 3. We'll look at the other one and everything looks fine. So if we're going to multiply this one, right, it doesn't matter what method you choose. I'm going to go with the grid. Let's not go with a red box. Let's go this box, that way it doesn't stand out too much. We'll put a line here and a line here, and then we'll go across, and then we'll go across, and then we'll fill out our information. We can put x squared plus 0x minus 3. We can put x squared plus 3x and then minus 1. So again, when we're doing this, we're just going to multiply. First row to every column. So this would be x to the 4th power. This would be 3x to the 3rd. And this will be negative x squared. Go to the next row. This will be 0x to the 3rd. This will be 0. This will be 0x squared, and this one will also be 0x. Go to the last row. You'll have negative 3x squared. You'll have negative 9x, and this one will be positive 3. So remember, that's not our answer. We have to combine like terms. And so after we combine like terms, this first box will give us x to the 4th. 0x to the 3rd plus 3x to the 3rd would be 3x to the 3rd. Negative 3x squared, 0x squared, and negative x squared would be negative 4x squared. Negative 9x and 0x would be negative 9x. And then we end up with plus 3. So that's a review of how to multiply with the area model. So if we looked at number 2, notice this is subtraction. Subtraction does not require an area model or anything like that. It requires us to find things that are like terms with each other. So for example, if I looked at this term and this term, they are alike. They both have x squares. So 5x squared, we stop in the middle, minus x squared. That would give us 4x squared. And then we can look at the middle terms. This is a negative 3x and a positive 2x. So negative 3x minus 2x would be negative 1x. So we put minus x. And then our last term, negative 7 minus negative 5. And that would give us negative 12. And so that would be the end of that. What? No, this is not negative 12. negative 7 minus negative to a positive. So we would end up with a minus 2 as our final answer. Let's see, did I subtract anything else wrong? Negative 3 minus 2. Yeah, I'm just challenging myself this morning. That would be a negative 5. Negative 3 minus 2 would be negative 5x. All right, let's see. Let's move on to the next one. Here we have division. So we have x to the third minus 8 and then x minus 2. So we're missing some terms in the dividend. So we would maybe rewrite this. So it would say x to the third plus 0x squared plus 0x and then minus 8. And all of that would be divided by x minus 2. So if we set it up, right, we would write x minus 2. We draw our line. We've got x to the third plus 0x squared plus 0x and then minus 8. Remember, we always divide with this very first term here in the front. So x goes into x to the third, x squared times, we do the distributive property, so we get x to the third, and then minus or negative 2x squared. These cancel, so 0 minus negative 2 is 2. X squared, we bring this term down, so we bring down the 0x, and we start over. So x goes into 2x squared 2x times. And so you get 2x squared, and then you get negative 4x. Put those parentheses. This cancels out. 0 minus negative 4 is 4, so we put 4x. We bring down the minus 8, and then x goes into 4x 4 times. And so you end up with 4x minus 8, and then of course our remainder is 0. Right, number 4, they have us multiplying 3 things together. And this is a case where you may use different methods to do different things. Like, for example, if I look at this one, I'm not going to draw a box for these two. I'm going to do the distributive property, where I multiply x times x, and I get x squared, and then x times negative 2, and I get negative 2x, and then I multiply this one here, I get an x, and then I multiply this one, and I get a negative 2. So if I combine like terms, I'm going to get x squared, negative 2x plus x. It's going to give me negative x, and then minus 2. Now I'm going to multiply that one to x plus 3. So again, you could either do the distributive property again, which is what I'll do this time just to show that one more time, is we would take this x and we're going to multiply it to everything on this part. So that would be x to the third power. And then x times negative x is negative x squared. And then you get negative 2x. And then we'll do the same thing with the 3. This one will multiply to here, so you'll get a 3x squared. Then you get a negative 3x. And then you'll get a negative 6. So I'm going to combine like terms. There's no other terms with a cube, so that's part of our final answer. Or is there another one? Oh, there is. This one, let's see, x, no. So that would be x to the third power. We have a negative x squared and a positive 3x squared. That would give us a 2x x squared negative 2x minus a 3x is a negative 5x, and then we have a minus 6. So that's using the distributive property and not using the area model at all as an option. Number 5, this is straight up subtraction of like terms. So x minus x minus x. So these first two, x minus x, will be 0, and you minus another x, and you're going to get negative x. 1 minus negative 2 is 3, and then 3 minus 3 is 0. So you don't have to put the 0, and the final answer is negative x. Right, if we looked at number 6, again, do any design or operation that you want. So let's say this time I wanted to do the area model. Right, last time I did distributive properties, so let's say I go area model. I would need 2 rows. So there's my 2 rows, and I'm going to need 3 columns. Right, we'll space that out a little bit better. That looks nicer. And so we put x plus 2 here on the side, 2x squared minus 5x, and then plus 7. So we fill it in. 2x squared times x is 2x to the third. This one is negative 5x squared. This one is 7x. Next row, we're going to get 4x squared. We'll get negative 10x, and then we'll get 14. Remember, this is not your final answer. We need to pull out the like terms for each diagonal row. So the first one stays as is. So we get 2x squared. 4x squared plus negative 5x squared is, I'm sorry, this is a third up here. This will become, for number 6, a negative x squared. Negative 10x plus 7x is negative 3x. And then we leave the 14 there. So that's how that particular one works out. If we tried another division one, we take a look at it. We have our cubic or squared, our linear, and our constant term. And then so we have x minus 9. And so we want to divide this information out and see what we get. So remember, if we wanted to say do the boxes, the rows are going to be 1 more than the degree of the divisor. So the degree here is a 1. So we're going to need 2 rows. And for columns, 3 minus 1 is 2. I need 1 more than the difference. So I'm going to need 3 columns. One more than the difference. So we draw our box. Right? Let's see, we're going to need 2 rows and 3 columns. That should be ample space. Here's 2 rows, 3 columns. And again, if you're doing this one and you prefer long division, that's fine. I'm just changing it up this time to show different methods. So here we have x minus 9. Now remember, the other parts don't go at the top for this. They go around this because this would be our where we would get. So we would put x to the third here, negative 2x squared here, negative 65x, and then 18. Noticed everything fit. So this 18 can automatically go in this box. This x to the third can automatically go here. And so 18 divided by negative 9 is negative 2. So we'll put a negative 2 here at the top. And then x to the third divided by x is x squared. And so now if I wanted to get that middle piece, I would multiply these two to get negative 2x. If I wanted to fill in some other ones, I can. This one and this one would be negative 9x squared. And the reason why I say that is maybe you see this negative 65 and you don't like that. You don't always have to work from this direction. You could choose this corner and say, oh, I like this negative 2x squared better. Because you might say, oh, I know, this is 7x squared. Whereas you might have a harder time thinking about this one. So that's just an option to consider. And so now, if I do 7x squared divided by x, I'm going to get 7x. So that makes my answer, the quotient, x squared plus 7x minus 2. So again, these just kind of get redundant. They're designed for additional practice. Here you could see another subtraction problem. In this particular problem, the like terms are not always in the same order, so you have to look a little bit harder. So for example, you've got your x squared here, but your other one is in the back. So in number 8, x squared minus 2x squared, and you're going to get negative x squared. If I looked at the linear terms, negative 3x and negative x, so negative 3 minus negative 1, I'm going to get negative 2x, and 2 minus 2 would go to 0. So again, remember, this is really just about looking at strategy, which way you want to solve things and so forth. So in this case, right, this is multiplication. We're going to do the area model. We're going to need a 3 by 3 because everything is there. But one of the things that you want to note in this particular 3 by 3 model is that it's not written in standard form. So you want to do that if you're going to be easily successful. Like for example, this is x squared, this is x to the first, this is no x, so this one's fine. X squared minus 3x and then plus 2. I want to rearrange these terms so the 2x squared goes first, and then the minus x, and then the plus 2. And then you would solve it. After you solve it, I'll just give you the result. Right? I won't do all the work this time. You would get 2x to the fourth minus 7x to the third plus 9x squared minus 8x and then plus 4. Here in the division, we take a look. We got a cubic, a quadratic, a linear, and a constant. You got your x minus 3. So you could really do it either way that you wanted to do that particular one, and so forth. The answer for this one, by the way, whether you choose long division or area model, is x squared plus 2x plus 1. Okay, so that was the first 10. I'm going to stop at 10. That's plenty enough for you to go back and watch. If you do try 11 through 15, you're welcome to ask me for questions. If you get stuck on one or if you need the answer, I can let you know. Don't worry about exercise 16, 17, 18, really any of the other exercises. Just becomes redundant practice. At this point, it would be best suited to move into the problem set and just get some practice done there.